Okay, so this first question looks like a multiple choice question, but it's not. Um, I don't do a lot of multiple choice questions because I don't really know if you know it, if you got the question right, and you don't either. But some questions are hard to ask in a non multiple choice way, and sometimes it's just easy to make calculation errors on a question. So sometimes I'll have it as a multiple choice question, but you have to show your work so that if you make a careless mistake in your calculations, you won't get one of the answers that's there, and you'll know that you've made a mistake and you'll try and fix it. Okay, so it just gives you another opportunity to get the right answer. Okay, so for this one, to justify your answer, the answer is, well, okay, if I do them in order, so for option A, 4 times 2 is 8, so that's okay. And 1.5 times 2 does not equal 2.5, so that can't be right. Okay, the two being the scale factor, right? So for B, okay, a different way to look at it would be that 12 over 8 should equal 3.5 over 2.5, right? Does that make sense? These are the similar corresponding sides. The proportions should be similar. And this is 1.5, and this is not 1.5, so it's not, I don't know what it is, but it's not going to be the same. It's not equal. If I look at C, 16 over 8, does that equal 5 over 2.5? Yes, it does. So C is the correct answer. Okay? For triangle ABC, the data for triangle ABC is shown in the first line of the table. It's enlarged, so the area is 270 centimeters squared. Which triangle is the enlargement of ABC? Well, they all have an area of 270, so that doesn't help me. The area scale factor is the image over the original, so that's set to 70 over 7.5 because that was the original one. And 270 divided by 7.5 is 36. So I can eliminate, oops, I can eliminate this one and this one, right? Because those have got an area scale factor of not 36. And then my linear scale factor is the square root of the area scale factor. So it's the square root of 36, so it's 6. Oh, so that still works for both. All right, let's try something else. What's different? The length of the base. The length of the base is different in the two that I have left. So scale equals image over original, and I know that scale. So I'm looking for the length of the image. So image is original times the scale. So if I'm looking at the image, the original base length times the scale, and that would be linear scale factor, would be 5 times 6 is 30. So it has to be, that's the only one that works. So the answer is DEF. Okay. You could have also done image is original times scale for the height of the triangle. 3 times 6 is 18. That works as well. Okay. But neither of those gets you 36 and 16 for the sides, or the base and the height. Okay. All right, question 3, a 1 to 7 scale model of a shopping cart. So scale equals image over original. 1 over 7 is image over 15. So the image is, wait. Sorry, I got this backwards. The image is the 15. And I'm looking for the original. There we go. So my original is 15 times 7, which is 105 centimeters. And then, because I'm having a good day, I notice I could probably just do that for all of these. I can go 8.4 times 7, which gets me 58.8 centimeters wide. And 13.4 times 7 is 93.8 centimeters long. Yes, and that is the problem with using the O for original. So if that's going to be an issue for you, write something else. I mean, maybe write orig. Okay. Sure, if that works for you and you don't get that confused with area, that's just fine, right? You just do whatever abbreviations make sense to you. Okay. Okay. Any questions on this page? Okay. All right. This is one that probably made you go eek. A cook has a set of 4 mixing bowls with lids. The bowls stack inside each other and are similar to each other. The surface areas of the largest bowls are 2,300 centimeters squared and 1,100 centimeters squared. Sorry. The scale factor is the same for from each bowl to the next smaller bowl. So I'm going to actually name my bowls. So I'm going to call them. Oh, what are the Starbucks ones for the bowls? What's the, because they have 4 sizes at Starbucks. Okay. Let's call them, I don't want to use A, B, C, D. Let's use E, F, G, and H. Okay, so E being the largest bowl. Whoops. E being the largest. Okay, so the largest I know is 2,300. The next one down is 1,100. Okay, so my scale is, let's put the largest on the top, larger one and the smaller one. Oops. So this is a linear, no, this is a scale factor. Okay, hang on. So now I'm running into a problem where I've got S meaning 2 different things, so I'm going to change my mind about this. I'm going to use scale equals big over little. Okay, when I'm comparing two. One of them's bigger, one's littler. Okay. So my scale, and the scale factor, the area scale factor for all of them, I'll be clear that this is the area scale factor I'm talking about, is going to be the same between any 2 consecutive bowls. So it's 2,300 over 1,100, which reduces to 23 over 11. And I could change that to a decimal, but I'm not going to. It's just as easy to leave it as a fraction like that because we're doing proportions anyway, so we're not really dealing with it as a fraction. And then my scale is going to be the bigger one over the littler one. So 23 over 11, because that's now my scale. And now I'm going to compare F and G. So it's going to be bowl, doesn't say bowl, I don't know what that says. Bowl F over bowl G. Okay? So this is really about just keeping myself organized as to what I'm doing. Now, I know how big bowl F is, don't I? Bowl F is 1,100. So this is 1,100 over the size of bowl G. So bowl G is 11 times 1,100 divided by 23, which is 526 centimeters squared. And I'm going to write that up here, 526 centimeters squared. Yeah, I could. I should. So I'm going to do this again. The scale is going to be um, bold G over bold H now. Okay. So 23 over 11 equals 526 over bold H. So H is going to be 11 times 526 divided by 23. So H comes out to 252 centimeters squared. All right. Now, do these numbers make sense? Well, when I went from the first one to the second one, it was a little less than half as big, right? Just eyeballing it, 1100 is a little less than 2300. So a little bit less, half of 1100 would be 5500, so we're a little less than that. And half of 526, 252, that works. Like these seem reasonable numbers, right? All right. Question 5. Max, I noticed that you're not looking at your quiz. Maybe you should take the quiz out and be marking it, because that's what we're doing now and going over it, okay? The base and height of a trapezoid with an area of 35 centimeters squared will be enlarged by a scale factor of 4. Determine the area of the enlarged trapezoid. So we're comparing area to area, so we need an area scale factor, right? So the area scale factor is the linear scale factor squared. So that's 4 squared, which is 16. So the area scale factor is the area of the image over the area of the original. So 16 equals the area of the image over 35, and the area of the image is 16 times 35, which is 560 centimeters squared. That's my answer. Question 6. Jason reduces this figure by a scale factor of 1/4. Determine the area of the reduced figure to the nearest tenth of a square unit. Well, the first thing that freaks everybody out on this question is that you don't know what the area of the figure is, but you can count it. Okay? So this bit up at the top, if I do that and I were to flip this piece over here, that's going to take up 1.5 squares. So that's 1.5. This chunk here is 1. This row is 3. This row is 3. And then this bottom chunk here, if I take this piece here and move it over here, that takes up 2 whole squares. And then there's 2 squares here, so that's 4. And 4, 5, 6, 7, 8, 9, 10, 11, 12.5. So I just need to add that up, get 12.5 for my total area of that. So my area initial is 12.5. I'm comparing areas, so I need an area scale factor, which is going to be the linear scale factor squared. That's 1/4 squared, which is 1 over 16. And the area scale factor is the area of the image. Oops, I'm sorry, this is my original, not my image. So it's going to be 1 over 16 equals 12 point, wait. No, I'm still trying to put that in the image spot. Sorry. This is the area of the image on top. And the area of the original is 12.5. So the area of the image is 12.5 divided by 16 times 1. And the area of the image is 0.078125, which rounds to 0.8. Do you have to write all that down to show your work? Not all of it. For example, I'll just show you in red what I have written on my answer key. Right up here where it says scale factor is 1/4, I have the area scale factor is 1 over 16. I didn't show how I got that, but that's like one of the things we've done enough times that you don't have to show how you get it, but you need to write down what it is, and that seems like a good place to put it because that's where I got it. And somewhere you do have to write down what the original number is 12.5. Okay, and then you need to set up this proportion or a similar equation that, you know, if you made the equation, if you used the area of the image is the area of the original times the area scale factor. If you did that and then you filled it in, that would be fine too. Okay, this question is legitimately hard. This one here, number 7. The scale factor for two similar circles is 1 to 4. So that's the linear scale factor. So I'm immediately going to write down that the area scale factor is 1 over 16. All right. And the sum of their areas is 153 centimeters squared. How big is each circle? Well, I don't know. So let's write down what we know. We know that the area scale factor is the area of, well, let's call it the smaller circle, and the area of the larger circle. Because the bigger numbers on the bottom, the bigger circle needs to go on the bottom of our ratio here. Okay. Do I know what the area of the smaller circle is and what the area of the larger circle is? Do we? Not yet, right? But how about if I say, so I can put in the 1 over 16 here. And what if I say that the area of the small circle is just x? Because I don't know what it is, right? And if the area of the small circle is x, what's the area of the large circle? It could be, but we actually know something about the two of them, and we know that the bigger one is going to have 16 times the area of the smaller one, so it's going to be 16 times x. Yeah, so 16x. Okay. So that's good, but it's not particularly helpful the way it is right now. But I do know that the sum of their areas is 153 centimeters squared. So x plus 16x has to equal 153. So 17x equals 153, and x equals 9. So the small circle is 9 centimeters squared. And the large is 16x, which is 16 times 9, which is 144. So my other one is 144 centimeters squared. And then I'm going to take my calculator out and just make sure those actually do add up to 153, which they do. Okay. I do. Standing joke in my family that I can't add, can't count. All right, next page. Circle A has an area of 5 centimeters squared, and similar circle B has an area of 45 centimeters squared. Determine what scale factor makes circle B an enlargement of circle A. So if B is the enlargement, then A is the original, and this is the image. Okay, and area scale factor is the area of the image over the area of the original. So that's 45 over 5, which is 9. And then the linear scale factor, because they're asking for a scale factor, that means they're asking for the linear scale factor. If they don't specify, it's always the linear. So the linear scale factor is the square root of the area scale factor, so it's the square root of 9, which is 3. Question 9. A rectangle A is 6 centimeters high, 9 centimeters long, 15 centimeters wide. Rectangle B is bigger. The two rectangles, those are actually rectangular prisms, but just going to make a note of that for next time. Okay, I'll do that later. By what factor is the surface area of rectangle B? Well, it doesn't actually ask me how much bigger it is. It's how, by what scale, what factor is it. So it's asking me for the area scale factor. Okay. So, so this is going to be the area scale factor. So the linear scale factor is going to be the bigger one over the smaller one, just 7 over 3. Because we're talking about it's an enlargement, right? B is bigger than A. How many times bigger is it? I'm looking for an enlargement number, so I'm going to put the bigger number on top. Okay, so the linear scale factor is 7 over 3. The area scale factor is going to be 7 squared over 3 squared, which is 49 over 9. So there's my answer. Or if you made it into a decimal, it's 5.4 repeating. So either of those is okay. Question 10 is exactly like one we did on the other page, even to the scale. It's 1 to 7. So you're just going to go all these numbers times 7. 46.3 times 7 is 324.1 centimeters. Make sure you're including units on this one. And then you get, oops, sorry, I put my decimal in the wrong place. It's a really big snowmobile. No, that's right. Sorry, 0.1. There we go. And 119 centimeters and 133 centimeters. Question 11. We're given the dimensions, and it's in a scale of, these are the actual, and so this time I just need to divide them all by 4. So scale equals image over actual. Actual equals image divided by scale. So it's the, wait, what am I doing? Actual image. We're asked for the image. Wait a minute, scale, oh, scale is 1 over 4, right. Okay, let's try that again. Scale equals image over original. Scale is 1 over 4, and that equals the image over the original size. So the image is the original divided by 4. So we get 22.5 centimeters, 44 centimeters, 16.25 centimeters. All right, we're almost done. 3 more questions. A stage director needs a large chess pawn for a scene. The pawn in her chess set is 35 millimeters tall, and she estimates that the height of the enlarged pawn must be 700 millimeters. How many times greater will the surface area of the larger pawn be? Well, the linear scale factor is going to be the image over the original. So that's going to be 700 over 35, and they're both in millimeters, so we can leave it that way. And that equals 20. But we're talking about how many times greater the surface area is going to be, so that's, we need the area scale factor, which is going to be the linear scale factor squared, which is 20 squared, which is 400. So the answer is 400 times. Questions 13 and 14. If you didn't get them, it's probably because you were overthinking this and making it much harder than it actually is. These questions are just asking you for the scale factor, because the scale is the area of the large one over the area of the small one, right? That's all it's asking you for. So if the linear scale factor on this one, the linear scale factor is 3.2, if I want to write that as a ratio, it's 3.2 over 1, right? So the area scale factor is going to be 3.2 over 1 squared. So it's 10.24 over 1. So the value of that is actually just 10.24. But I would accept either of those. And question 14, the dimensions are enlarged by a scale factor of 16.5. So that's the linear scale factor, right? So it's just, the answer is just 16.5. Because if the perimeter, whatever the perimeter is, it's going to be 16.5 times bigger than the perimeter of the smaller one, right? Because that's the linear scale factor. Does that make sense? Okay. Okay, what I would really like you to do is take a look at this quiz and give yourself a mark from 1 to 6. You know, 6 being almost perfect understanding. I can put this up on the screen. 6 being like you got it all right. 5 is you really got it. You have maybe one little mistake on it. 4, you knew what you were doing, but didn't get them all right, like a B. 3, you're starting to understand things but missing major concepts. 2 is just barely enough to get credit for it, and 1 is, yeah, I need to do a lot more work here. I don't have enough to pass. Okay. And I'm just going to come around and record that at some point during the class, just because I think it's really useful for me to have how you did on this quiz, but I want you to keep it because you've already done, you've done the corrections to it, and I want you to have it to use as a resource. But I do want to see how you did on this so I can see how the class is doing as a whole. Okay. All right, I can stop recording that.